Welcome back everyone. So in the last video we solved jump game 2 part 1, and in that part 1 we discussed the recursive solution and recursive memoized solution and solution using the DP. But there is one solution that is left out, and that is a solution based on the single traversal of the array. So in this video we are going to solve the jump game 2 again in a single traversal of the array in big of n and big of 1 space complexity. So let's dive in. So we are given a zero index array of integer nums of length n. You are initially positioned at index 0. Now each element in nums I represents the maximum length of forward jump from index I. In other words, if you are at index I, you can jump to any index I plus j where j is less than or equal to nums at I and greater than or equal to 0. Also, I plus j should be less than n. Now we have to return the number of jumps to reach the index n minus 1. And the test case are generated such that you can reach an index n minus 1 always. Okay, so let's see how we are going to solve this. So we'll first understand example 1. Okay, so what we have to do is we have to reach from the 0th index to the last index. Okay, so first let me give an intuition behind this. So we will work in the solution based on the ranges. So for example, you are at 0th index. So from 0th index you can go to first index and second index, and from this you can directly go to the 4th index. So in one jump you will reach at a maximum of this range. Okay, and in the second jump you will directly reach to the this. So the first jump will be up until this range, and in the second jump from this range, okay, you can directly jump to this range. So basically this range and this range. Okay, and you are standing at this position. So in one jump you move on to this range, and this is the second end. So now let's see how this works. So we will maintain three variables. The first variable is obviously how many jumps we have to take. So initially it will be 0. The next variable is the maximum reachable index, okay, up until now. So the maximum reachable index up until now, so it is 0, and the current end. So I'll tell you what this current end means. So current end will also be 0. So current end is the end of the next range. So initially the range will be this one. Okay, the next range is this, the last range is this. Okay, so current end is this index. So current end is this index, and in this current end is this index. So we will run this loop from 0 index to n minus 2 only. So this is the range we will traverse. So now let's see how this works. Okay, so you are at 0 position. Now from 0th position, what is the maximum reachable index? So the maximum reachable index will be 0, 1, 2, 3, 4, will be 0 plus 2, that is 2. Now you are at the end of the first range, which means you have to take a jump to move to the next range, right? So you will take a jump because you are at 0th index, you have to take a jump to reach the next range, and the next range end will be 2. So the next range end will be this one. Okay, now you come at this place and you see the maximum reachable index from this position is 3 plus 1, that is, so the maximum reachable index will be 4. Okay, now you come at this position, the maximum reachable index is 3, but we are already at maximum of 4, so we'll not update. But now you are at the end of the second range. Now if you are at the end of the second range, which means you have to jump to the next range. So we will jump to the next range, and update the current end. So the next range end will be 4. So this is the next range end. Now we'll come at this position. Okay, so the maximum reachable from this is 3 plus 1, 4, which we are already at. Now this is the end of the loop. So we will run this loop until this range and not the last range. Because if we are at n minus 2, which means we have already taken sufficient jumps to reach the next end. So when we are here, we took the jump to this range. Okay, and when we are end of this range, we took the jump to the next range. Okay, so this is the next range. So end of maximum reachable index is 4. So this is the next range, and we already took the jump in that next range. So the total jumps are 2. The first jump in this range and the second is this range. Now let us see the next example. Okay, so in this example, the jumps will be 0, maximum reachable is also 0, and the current end will be 0. So these are index 0, 1, 2, 3, 4, 4. So now you are at this position, and from this position you can reach maximum of 2 index. So the maximum reachable will be 2, but you are at the end of the first range. Okay, so you'll have to take a jump. So we'll take a jump and update the current end. So the current end will now be 2. So this was the first range, this is the second range. So you are at this position. Now at this position, what is the maximum number of jumps you can take? You can take 3 plus 1, 4. So you can reach a maximum of 4th index. So the maximum reachable is 4. You came at this position. What is the maximum reachable? 2 plus 0, that is 2, but we can reach maximum of 4. So we will not update. But now you are at the end of this range. So you will have to take a jump to the next range. So we'll update it to 2, which means from this to this, you have to take a jump. Okay, so we took the jump and we have to update the current end, that is 4. Now we come at this place and you see we can reach maximum 4, so we'll not update. Now this is the end of the traversing, which means the total number of jumps we have to take is 2. So first is inside this range, and from this range onward we'll take a direct jump to last range, which will make us reach to the last index. So now let's look at one random example. So let's see. So let's say we have this array. So first we'll take 2 jump, then 0, 1, 1, 3, 0, 0, 2. Okay, and indexes are 0, 1, 2, 3, 4, 5, 6, and 7. So let's see. So the jumps will be 0, maximum reachable index is also 0, and the current end will also be 0. So this is the first range. Now from first range, the maximum you can reach is second index. So maximum reachable is 2. Okay, now we are also at the end of the current range, so we'll have to take a jump, right? So we'll take a jump and update the current end, that is 2. Now we are at first index, so we'll take maximum jump of 1 plus 0, that is 1, but we can already reach maximum index 2, so we'll not update. Now we are at this position, so at this position the maximum we can reach is 3, but we are also at the end of this second range, so we will take a jump, we'll update the current end to 3. Now we'll come at the third index, so maximum we can reach is 4. So after reaching the 4, we are also at the end of this range, so this was this range, so we'll have to take a jump and update the current end. Now we go to the 4. So at 4, the maximum we can reach is 7. So maximum reachable index is 7. Also, we are at the end of this range. So we'll have to take a jump. So we took the jump and update the current end to 7. Now we come at 5. The maximum we can reach is 5. But the maximum we can reach is 7. So we'll not update. We move on forward. The maximum we can reach here is 6. But we can reach maximum 7. So we'll not update. And that's the end of this iteration. So we'll not go to the last index. Okay, so up until this and this, the maximum jumps we have to take is 4. So the first jump is inside this range, the second jump inside this range, third jump, and the fourth jump is inside this final range, and we were able to reach at the last index. Now let us see one more example where it is impossible to reach at the last index. In question it is already mentioned that there is always a way to reach from 0 to the last index. But just for understanding, we'll take one more example where we will not be able to reach the last index. So we'll take the same example, but we'll tweak the jump counts. So 2, 0, 1, 1, 1, 0, 0, 2. Okay. So 0, 1, 2, 3, 4, 5, 6, and 7. So jumps will be 0, maximum reachable is 0, and current end will also be 0. So this is the first range. So the maximum from this index you can reach is 2. So maximum reachable is 2. You are at the end of this range, so we'll have to take a jump and update the current end. Now from this you can reach maximum of 1, we will not update. From this you will reach maximum of 2 plus 1 3, so we'll update, but you are also at the end of this range, so we'll have to take a jump and update the current end. Now you are at this position, so the maximum you can reach is 4. Okay, and you are also at the end of this range, so we'll have to take a jump, update the current end. Okay, now you are at this position, the maximum you can reach is 5. Okay, you are also at this end of this range, so you will have to take a jump and update the current end. Now you are at 5, the maximum you can reach is 5. Okay, but the maximum already is 5, so we will not update, but you are also at the end of this range, so you will have to take a jump and update the current end, that is already 5. Now you are at 6. Okay, now you see the maximum reachable is what, 5, but you are at index 7. What does this mean? This means that you are at an invalid index, you cannot reach that point. Okay, so if you cannot reach that point, which means there is no way you can reach from index 0 to the last index. Okay, so now we will code this solution. So we have int jumps initially will be 0, maximum reachable index will be 0, current end of this range is also 0, and the size is nums dot size. We will run this loop from I is 0 to I is less than n minus 1 I plus plus. Okay, now the maximum reachable is maximum of maximum reachable or I plus nums at I. Now if we are at the end of this range, then the jumps will increase, we have to take a jump, and the next range end will be maximum reachable index. Also if the current end is greater than equal to n, which means we will never go inside the if condition again, which means we can break out of this loop early to save some iterations. Now at the end we will see if the maximum reachable index is less than n minus 1, which means we never reached the last index. In that case we have to return minus 1, else we'll return jumps. Now in the question it mentioned that there is always a path from 0th index to last index, so we can directly return the jumps, but just for understanding we are returning minus 1 also, but as per the question this case will never arise, so we can safely return jumps also. So now let's see if this works or not. Okay, so our initial test case has been passed and now we will submit this, and our solution got accepted. Now just to recap, what we did is we will start with the first index, and that's also the end of this first range. Now we are at the end of this range, which means we have to take a jump to the next range. Okay, and to take jump to the next range we will update the end of the next range also. Okay, so by doing this we will run this loop from 0 to n minus 2th index, and finally we will return the jumps. So that's it.